Hello and welcome to a deep dive discussion on unanticipated but often serious API vulnerabilities. We're now joined by cybersecurity expert Dr. Katie Paxton-Fear as she shares some spooky stories of bugs and not necessarily best practices that could lead to gaping API security holes and data leaks. I'm Dana Gardner, Director of Content at Traceable AI, your host for this series of API risk assessment and remediation discussions. Katie is currently a lecturer on cybersecurity at Manchester Metropolitan University in the UK, and she's a researcher around the intersection of AI, ML, and InfoSec. She earned a PhD from Cranfield University and she's an accomplished detective of security vulnerabilities for such organizations as Verizon Media and the US Department of Defense. Stay with us now as we learn how API security risks essentially never end because APIs are entwined with many apps and endpoints. APIs are so often used differently, making for a dynamic and perpetual attack surface. These never-ending weaknesses include API versioning snafus, WordPress use risks, security tool evaluation no-nos, and GitHub use best practices. And so now, please join me in welcoming Dr. Katie Paxton-Fear as she unpacks the ways that we can better protect ourselves, our organizations, and our individual best practices as developers and practitioners from these very same types of vulnerabilities.
Hey everyone, thank you Dana for that introduction. Today I would like to invite you to come round the proverbial campfire and listen well as I tell you some spooky stories from beyond the grave. This is really just some interesting stories of bugs that I found that I think are kind of interesting and that demonstrate the kind of variety you get when you do API hacking, because actually API hacking never really ends fully at the API, because APIs tend to be really entwined with things like mobile apps or desktop apps or other things that actually you can start at an API and end up in a completely different place. So these all have the similar theme of being beyond the traditional attack surface. Now, these are some fun, weird vulnerabilities and forgotten pieces of code. It's like fun security stories, bug bounty archaeology based on my own experience, and secrets best kept in the dark. So let's start with API versioning, a story of backwards compatibility. So API versioning is something really common. When developers release new APIs, they tend to, go from version 1 to 1.1 to 1.2. And each one of those might fix some security flaws, might fix some usability problems, might change the input and the output. Now, this story in particular focuses on developer APIs. Now, APIs designed at developers have a lot more documentation than kind of black box APIs. So this is, for example, the Twitter API, and you can see it tells you a lot of information about this version 1.1 endpoint and how it actually changes from 1.1 to version 2. So you can see a more traditional RESTful API in version 1.1, for example. And then you can see like the version 2 API points are a bit different. But because you get a lot of information about how the API works and how, like, what inputs it's wanting, what outputs it's wanting, what resources it uses, what it returns, you have like a lot of information about how the API works you wouldn't necessarily ordinarily have if you were looking at like a client's internal API or a mobile API. Now, with that in mind, you can see here that it discloses to us that there's a version 1.1 and version 2. Now, often what will happen is that APIs will get deprecated. So we version 2 will get released and then version 1 will be completely switched off. Developers don't really like doing that because if you switch it completely off, what tends to happen is that customers complain about it. Like customers who may be used to data being a certain format don't want to update their application, so often it takes some time between version 1 to version 2 or version 1.1 to version 1.2 that actually they keep the old version up. Now, that isn't that unusual. Usually it'll only be up for like a little bit longer, but unfortunately in this particular case, version 1.1 was just left up. It might have been forgotten about, it might have been that they just wanted to keep it up for customer reasons, but for whatever reason it was still accessible. But because it was still accessible, the security flaws for 1.1 were still there. The security flaws that had been fixed by later versions still existed. And in this case, I'm using the Twitter API as an example. It wasn't actually in the Twitter API, it was in a different API. But you could essentially bypass the security controls by simply using the old version. And a lot of developers don't actually think that when you use like a version, like 1 of something or get a security report for version 2, they don't necessarily update version 1 either. So like you can have this really weird situation where version 1 is vulnerable to bugs you've already fixed, but it's still out there. And it happens all the time, like it's so often. So my next story is a long forgotten blog, and this is about WordPress. And you might be thinking, Katie, what's the link here between WordPress and APIs? And the answer is databases. So WordPress, if you're not necessarily sure, is this like nice content management blog system. Well, I say nice. It was kind of built as a blog, and then people like retrofit like e-commerce systems in there, and they retrofit like APIs in there, or their WordPress will connect to APIs. So you end up in this really weird situation where the person who owns the marketing blog has full control over WordPress, but doesn't not talk to the security team. The security team is off doing something else. They will often do things in what we would consider as security people an insecure way, but they don't really realize that because that's not their expertise. They just want to get content out there. And blogs used to be a lot more common than they are nowadays. In the old kind of model of like marketing, it used to be the case that they would kind of use social media to direct people into their marketing blogs. So they'd be like, hey, check out my new post. Versus the new model, because in the new model, what you have instead is a blog is just part of this like full social media strategy. And often these blogs just get left forgotten. And quite often, and the reason why I tell this story is really because this happened to me when I was a developer, is that we would have an API that would be insecure, that was needed for this marketing blog that marketing weren't even using. So you just have this massive security gap that you just can't bridge. And this is especially true of plugins. There are so many abandoned WordPress plugins. Like, it's genuinely scary where some of these were last updated, and they have so many websites that are using them. The most common one, which I think is hilarious, allows you to run exec. So exec is a way of kind of running PHP code as a string. And the fact that that is the most common and it's like purposely introducing remote code execution, and it's completely abandoned. There's a bunch of these though. And if you look at like CVEs just for WordPress, right? Like we see kind of code execution, we see directory traversal. And so how does that connect up to APIs? Well, often WordPress is not hosted on a separate database server. A lot of the time, and certainly in the case of this one that I'm thinking of, it was the same database server, just with a different database. And you know what else was on there? All the APIs. And as much as we were on top of dealing with the APIs and securing them and making sure that any updates went live, we weren't looking at WordPress because that was the person who does marketing's responsibility. And what did that end up with? Well, we were in this situation where, like, the database was completely vulnerable via WordPress, not via the actual thing we were securing. Now, my next story here is an oops I made as a developer. Now, as much as that story is a lot about when I was a developer, it wasn't really my fault. I didn't install WordPress. This one I definitely caused. This one I absolutely made a mistake on. So if you've ever been to a conference, and I'm sure plenty of people listening have been to a tech conference, you probably know tech FOMO. Like, you see somebody using a really neat tool, a really cool thing, and you get really excited. You're like, oh my God, I want to do it. I want to do it. I want to access that. Yeah, I'll pay money for it. And you see a demo and you're like, why aren't we doing that? It's such a better way of doing what we're doing. And what you end up having in your tech FOMO is kind of trying out things and seeing things and kind of just following the hype rather than doing like a proper security check. Because what you do is you download a file. You don't want to miss out on what other people are doing. Maybe it's a competitor. Maybe you're like, oh, I don't want to be behind our competitors. I can't tell you what the software is for obvious reasons. But essentially, we tried out this new data platform, exposed a few ports to the internet, moved servers months later. I only find out it's been running ever since. No one ever shut it off, and no one ever updated it, which meant that this kind of a piece of evaluation software that's still running on the servers when we moved them, and is still running to this day. No one's turned it off since. It's all still running. It's all still accessible and available. And, no one's updated it. No one's checked it. CVEs are some of the most easy things to fix, but you have to actually update them to get the fixes. Like, you can't just leave it on the old version and expect fixes. And in this case, this was like a pipeline application, so it's called Apache NiFi if you've used it before. But essentially, this got data from all kinds of sources. So it got data from different databases, different APIs that we were using, different external APIs, and kind of crunched it all together. And it's still running on this server. I don't think anyone's maintaining it from my old job. But again, if you want the easy fixes, you have to update. Now, finally, I want to end with talking about GitHub. So if you're familiar with as a developer, you might know that a lot of companies will use GitHub, and they might use it publicly to release software, but quite often they use it privately. Now, Git isn't the same as GitHub. So Git is the software that makes the Git repository, so hosts the code. It's local to the system. When you do a commit, it first does it onto your local system. GitHub will take those Git repositories and give them the web interface and then host them and stuff like that. So Git is the kind of software installed on your computer, and GitHub is just like a cloud version of it, if you like. If you want to think about it in a different way, if you use Microsoft products, Git is like Word. You can use Word without using OneDrive. If you use them together, it's great. You have access to the cloud. You don't have to use them together. You can just use Word on its own. And GitHub is great for all kinds of security testing. My favorite one is GitHub Issues. So if you go onto software, my favorite is e-commerce software. You can actually see people complaining about security issues. In this case, the price is getting doubly discounted. There's no special rule here. It's just getting discounted. And you can see that the reply here is this needs review, whatever, but that is still vulnerable to an attack on the discount. And on top of that, you also have developer discussion where you can see people talking about code and being talking about the discussion. In this case, this was when there was a backdoor put into PHP. People were commenting on the actual commit and talking about it. So you kind of have this discussion element where you can see what people are doing in their software and like what they're kind of having trouble with and what kind of issues there might be. And that's really cool and that's really useful, especially if you're like me, black box on the outside. However, you can also search for secrets. Now, there is like GitHub docs, but the tool that I really like is called Trufflehog. And what Trufflehog will do is find API keys for things like AWS. Now, you can kind of do this initially by just using a GitHub search. But if you know, say, for example, an organization, you can look through organizations' repositories, look through the commits, and see where there used to be an API key. Maybe it's been removed, but it was there at one point, which means that you are still able to see it. And this is really great for finding external API keys where developers are accessing something, especially if it's a paid resource. Now, a lot of companies won't honor like Google Maps is a common one. So in Google Maps case, you pay per access. If you do get your key abused, Google Maps won't actually charge you for the like abuse amount, but they will kind of recognize it and like stop the account from working. But some of them won't, and especially things like AWS, you have a ton of access to a company's like server infrastructure if you're using AWS. Now, what do I really get from these like 5 short stories? Well, I'd like to talk a little bit about the changing attitudes in security, because vulnerabilities are like spilt milk. You shouldn't cry over having a single vulnerability. If you make software, if you make APIs, you are going to have vulnerabilities. It's just like, it just happens. Developers make mistakes. They're not committing moral sins when they make mistakes. Quite often it tends to be because they're trying to make life easier for themselves. They're trying to be more efficient in their programming. They're trying to make sure that they meet various deadlines. It's not a case that the developers are trying to maliciously like cause vulnerabilities in your software. It's quite often just mistakes. And if we treat vulnerabilities like they're disasters all the time and we start blaming developers, we end up in this really difficult situation where we kind of put security and pit it against productivity. And actually a better approach is always, instead of trying to pit two like teams against each other, to instead think about it as being collaborative. With that, what I mean is developers make mistakes. Yeah, they do. Introduce things like security policies, introduce things like regular testing, introduce tooling that supports the developers in recognizing when those mistakes have been made, because these are just, all the tools here are just things that, all the stories here are just things that people forgot. Like, this wasn't a case of an insider threat. This wasn't the case of a hacker getting in. This was just oopsies, right? I forgot to deal with that. Now, always my recommendation, especially if you're running any kind of like API, take inventory. Oh my gosh, you would not imagine how many vulnerabilities could be resolved by simply going, do we really need that publicly accessible? Like, what are we exposing? What's there? And by taking an inventory, by recognizing like every API point you have, or if you're running, multiple databases on a single database server, what the users actually have access to, when you start to take proper inventory, you can resolve so many security flaws that otherwise you would have to deal with, right? So that's my kind of advice. I hope you found those stories interesting. They're just some small stories about, kind of my experiences with APIs. To be honest, some of my most common API vulnerabilities tend to be bowlers, but I've already talked a lot about them on the Traceable webinar series, so I won't go too much into them here. But I hope those have been kind of interesting. I hope you've enjoyed the proverbial campfire, and let me know if you have any questions. Thank you very much for listening.
Katie, the numbers and types of unanticipated risks and consequences that arise from APIs and their many uses always astounds me. Hey, so please join me in thanking Dr. Katie Paxton-Fear for her valuable insights and deep expertise. We've learned to be on the lookout for bugs and not necessarily best use practices that can lead to gaping API vulnerabilities and data leaks. To learn more about API security best practices from Katie, follow her on Twitter at InsiderPhD. And to learn more about API discovery, cataloging, and observability for detecting risks early and completely, please look to Traceable AI as a great resource for information and for solutions. Visit us at traceable.ai and on LinkedIn and Twitter. Hey, thanks for joining, and look for more discussions from Katie and other cybersecurity experts from Traceable's AI Insights Discussions series. Thank you.